Hello everyone. Uh, Welcome to my channel. Uh, so this is the second episode of my live streaming series of developing agent framework from scratch in Go. Cool. Let's jump to. So I have refreshed the website a little bit. I've added this section of streams, right? And in this, I've added the project agent framework, which is currently ongoing. uh, this mm, for each stream episode that we're going to do, I'll write a accompanying article to just summarize uh, what happened in that stream, so that people can follow along just by reading article as well. So this is the first article. So the way I've designed it is that people can watch the stream on the left and then scroll through the article on the right, right? And I've also attached timestamp to the video so that when they click, they'll
A
jump
small
to
block.
that particular timestamp. So that is a quick overview of what this website is. To find this website, you can go to agentengineering.dev and streams. So in the first episode of the stream, what we developed was a basic uh, agent framework. So we first introduce our foundational block, where we discuss that there is a new uh, discipline being discovered called agent engineering, and uh, so we discussed uh, why we should build agents, open source agents, and why I'm doing this live stream. Right. So we went through a couple of definition what of an agent. It is something that perceives its environment and take actions to achieve some goal, right? So uh, what we're going to be developing is a coding agent. So most of his code would be to develop some sort of a software project. So in the first stream, I'll quickly go through what happens that uh, can follow along. So we set up a GitHub repository and install Go 1.24, and I'm using Golang for this particular project. Then we started by integrating the Claude's API. So instead of directly integrating with the Claude's API via HTTP, we have decided to use the Claude's Golang SDK, and we want to learn what are the abstractions that they have built for to make it easy to call API, so that we can we'll see how we translate them to a generic set of abstractions with which we can call both uh, OpenAI's and Gemini's models, right? So then we create the key, we set the key, we instantiated the client and send our first message to Claude, right? We print the result. Then we abstracted uh, this into its own method. We defined the system prompt. We accepted a goal in our CLI project from the user. Right? So the user can give goal what they want to do in a particular agent session, and then we construct them as input. Right? We just add this goal in front of for it to understand. Right? Then we went into tools and we developed a tool called list files. Uh, I'll not go into the details here because we are continuing to develop tool in this stream as well. So, so I'll spare the details here. Quickly, what we did was the list file tool, right? Where the agent can read files in the current directory or in the directory it chooses to, right? So, yeah. And then the final thing we did was the uh, agent loop, right? The agent loop is something like we do the inference, we maintain a conversation history, and uh, we make the tool call. I think this code is not written correctly. We go in the to the code that is fully written in our repo. I'll fix this in the blog. And yeah, with this setup, what we're able to do is uh, to go around, right? Uh, and give it a goal. So this is the overall thing that we built. Let's start with the plan today. So today, broadly, what we're going to do is what we have planned doing is uh, integrate with ChatGPT models and Gemini models and add more tools, right? But what we had not done last stream was to uh, add the read file tool, right? So we're going to do it this time around, and we're also going to do a bit of refactoring before we move into this plan. So we can mark this as done. Okay, simple tools to list file is done. Right, and this is also done. Right, so we're going to continue with a read file tool, right, and test the agent again. Then I'll talk broadly about how we can uh, create a generic interface so that we can our agent can interact with any models. Right. Cool. For the purpose of that, uh, to you know to prepare before stream to be able to talk to this model, I have created a .n file which has reference to all the API keys for ChatGPT, Claude, and Gemini. So I won't be able to. There's some problem with the stream. Okay, sorry about that. I was just trying to fix my streaming connection. Okay, let's start. Okay, cool. Looks good. Okay. Okay. So this is the code that we did last time. Mm. I know it's all in a single file currently, so that's why we might have to refactor a bit. And I was saying that I've created the environment file so that I don't have to deal with secret live string, right? So I'm going to add a git ignore file to avoid writing this into git history, right? So this is okay. So let's create a file called tools, right? And move all the tool related stuff here. Generate schema. Okay, this is good. Okay, we have a main file. We accept user goals. We define the tool definition, right? and we send it to Anthropic for the agent loop. This is the output and implementation. This also goes here. Okay, this looks a bit cleaner already. Okay, so we have the main file with the agent loop, right, and the run inference method. Okay, let's start another tool. Start to write another tool. So I like to add regions so that I can manage code a bit better. So that I can fold code like this. Okay, looks good. So this is a generic function, so I'll move it out. Right, so this is the list file tools and its implementation, right? So let's start with read file. So this is going to be our input. Let's call it path. So we have to come up with a schema for it. So for now, let's keep it to path, right? So that it's simple, you know. My OBS here. Okay. So what are we gonna do with the read tools, right? Okay. Let me think about. Right. Okay. Right. So this is a definition. Let's do file schema. Right. We need a schema. Input schema is the output. We need a function. That's it. Okay. Actually, do we really need an output? The output can just be a string at this moment, right? We need an implementation for this. Right, directory. It takes so sometime we would have to ask this implementation to parse the request because we already know what is the structure of input, right? And I don't think we need a struct for this output files, right? Because LLMs, they just need strings. They don't need some sort of a JSON or something. Okay. Okay, let's complete this function, then we can do a little refactoring. Right, so the function is os.read file path, right? And error reading file, we can just tell that to the LLM that there was error reading and what error happened, and it would be able to figure out what to do next. Right. Okay. Let's add another. Oh, this is the read file schema, and now we have to do is that we switch this list files, right? We have to switch on read file as well, right? More input struct. Okay, we don't need to. So this is the common thing we have to do. So we can abstract it out into some panic, right? Response to read file. Okay, looks good. I think this is a very quick implementation of read file tool. Right? Okay. One more change we have to do is use go.n. Let me import it. What is get github.com. I believe it's Joe. Okay, right. Okay, we have done. So basically, we'll be loading this file into our environment variable so that fatal. Yeah, for now, log fatal is fine. Later, we'll have some discipline of how we want to exit this application. So for now, I'm doing panic, so log fatal. It's fine, right? So I think with this, we should be able to ask the question. Okay, before that, let's build into some security upfront. We'll say that if it's a .n file, avoid reading it, right? .n return fmt dot and is not allowed to be read. Later we can create a generic way of excluding files, right? But now we can just hardcode because we have secrets here. We don't want them to be sent to any models or anything, right? And I recall another thing. Actually, we cannot panic here, right? Oh, panic on the JSON, right? Okay, that's fine. So if there is an error for n, right, we are sending it to the LLM saying there is a result and the error is true. Right? With this, we can say explain this project, right? Okay, right away. You need to pass tools of go as well. All right. So I'll help you understand. So it first lists file, then it's okay, then it read the readme file, right? Then it read the go mod file, it read the main.go file. So it read all the files, right? Let's see. Okay. Okay. And then can explain that this is an AI agent framework built in code, creates autonomous clouds API for purpose, implements agentic loop, in agent, available tools, how it works. Okay. Cloud. Okay. I think so. Our read tools is ready, and we are reading from the environment correctly. So this is good progress. Hmm. Okay. See how the stream is going. Looks good. Okay. Hmm. So now we did one layer of refactoring. We moved all the tools here, right? Now let's start the major refactor process, which is creating an abstraction for LLM access, right? So we want to be able to integrate with open ChatGPT and Gemini as well. So our agent should not directly have to integrate with these guys, right? So we have to create an abstraction over a few uh, models. Uh, so let's start with here. So type, right? So with types.go, what we need is start with the interface LLM, right? And main function there is run inference. As we saw, the run inference function, what it requires is input of messages and tools, right? So this is all it needs, right? So instead of sending Anthropic specific, we'll send our own definition here, right? So it requires messages and tools, right? And it return messages again, or it returns an error, right? So this is our interface. Let's define message, right? Now message struct is a bit tricky because uh, it can either be a text, right? Or as we have seen before, a message that we have to one of the message we have to return to uh, LLM sometimes is a tool result, right? So we create optional tool result, and in case of Anthropic, whenever we return tool result, we have to include the tool use as well before it. So whatever uh, agent, whatever LLM had responded with the tool use, we have to return it as is. Constant to this is tool, right? So a message can either be one of these three, right? I'll not add this as a pointer, right? Because we'll just check if these two are null, then uh, empty as a zero value, right? Then other thing we need is a role, right? So each message, when we send it back to LLM, we need to specify whether it's a system message or a and role. Constant, we have to define so yeah, okay. So user role, user, let's We have to define a type alias. So in Golang, we are allowed to define new structs using primitives, right? So, and so these are instant different. So there is assistant, and then there is system, right? So this is what message comes. There are 3 tabs of words. So let's finish with our tool result, right? Or tool use. So tool use, if you see, let me go back, right? We have to create an abstraction around the tool use of Anthropic, right? So let's say it is a tool use block, right? So in case this block is tool use, we'll see what it has, right? So it has primarily it has ID. So this I'm going inside the Anthropic library here to see how they define tool use, right? So we'll try to keep it same, right? So there is an ID. So if you see here in the instance, when it asks to wait, we are not printing the tool use ID. Okay. So yeah, we know that when Anthropic sends us this tool use block, it will create a distinct ID, and we have to return the tool result with the same feedback. That is the constraint they will have, and it will give us a JSON, right? That is the input. So that is the tool definition of. So this is an example of it, right? So we had this declare this as the tool input schema for list file. So it will return us this with the whole JSON, right? We can parse this and the name it will give us the name so that we can select on it. What is this type actually? Okay. Oh, this is just type, what type of block it is, and this is extra code to make it JSON parsable. Okay. So we don't need this, right? We need the first 3 in our abstraction. Okay. We need ID. String. We need name of the tool. We need input, which is JSON or raw message. That is our tool. And what we return back, we need to return the ID, as I said. For now, I'm not adding JSON tags to it because I'm not really sure if we need to parse it. Okay, what else the tool result requires, right? So tool result block, it requires the ID, it requires the content, and it requires is error or not, right? What do they call the content? Content, okay. So tool result is mostly a string, right? We send back string, and there is error, it's a boolean. Okay. Okay, this should be tools, and this should be tool definition. Okay, that brings us to another abstract type that we have to create, which is type tool definition, right? Okay, I think we have a hang of it. So we are creating an abstraction for this kind of stuff, right? So okay, there is also some tool definition here. Okay, it has name, description, input schema, and a function, right? So we are going to have something like that. So tool has a name, definition. Okay. Has a name. Let me see how the stream is doing. Okay. It has a name. It has a description. It has an input schema, right? I don't know what this should be. For now, I'll write that string. And it has a function, right? Let's call it func, which takes JSON.raw message. So the LLM will give us a raw message, right? And we have to return to the LLM a string or error. Okay, yeah. And based on the error, we can either send it as error or. So yeah, I think our interface is pretty solid, right? So this is a generic interface that we'll use towards all models, right? This looks good to me. Okay, we need this, right? We need one. We need one. It should be right. So in general, it can be actually an instance, any type, right? And then we will use our mechanism to convert this into a JSON schema of that type before we send it back to the LLM, right? So since our interface is ready, first thing we can do is move the Anthropic related code there so that we know that this is working, and then we can start with the ChatGPT integration. Right. So this is the tool definition. So this is all old code, right? We have migrated there. Okay. So first thing we do is need implementation. We need is a new setup, new client function, instantiate. Right. Give us an LLM client or an error. Right. Always return an error so that the caller can handle it, right? So what this does is this remove this there. Return okay. It will return let's create an Anthropic one right away. The specific code should go to Anthropic. For now this is fine. So okay, we'll save everything here, and to this we'll attach function topic LLM called run inference. So we have this this struct has to implement our LLM, right? So run inference. It needs messages, add tools, it returns back messages, error, right? So with this, now we can just say nil doesn't pose any error, and we will say for now new client will just return topic client. Okay, let's move this there actually, like, and add provider, right? If provider equal to topic client, right? And code. Okay, let me see it in the diff. Yeah. Read it. Oh, this is wrong. Okay, right. So we have the client, topic client, we return client. This is the client here. What does it return? It's not a pointer. Okay, no problem. Right. Okay. And this works because see, here we are returning LLM, but this, yes, this is returning a specific one, right? No need, right? Because it implements this interface. That's why you can use it exchangeably with. Okay. Now we move the run inference code, right? So this one goes here. Here we cannot panic. We return nil and error. Context. Now this client will get from A, right? So the client will get from here. So we created a client once, save it here, and each invocation we will just access this client, right? And messages is here. Okay, now we have to translate this messages from their definition to our side. So this is the one way we create it and we had to translate it back, right? So big messages is this, right? For in messages, okay, what is the difference between if message dot role user topic just pen. Okay. Okay, we can just use I, right? I, yes. New user message with okay, new user message with message text, right? Okay, this is just in case message param, right? Message. We'll figure out what the difference is here. Okay, what do we actually need here? Do we need message or this is message param, right? I don't know what is the difference between message and message param. So the Anthropic library. Okay, it's a instance of this. Different thing. Message parameters. Okay. So this one should be Anthropic string. No? Yeah. Let's find here how we were constructing the message, right? Okay, new text block. Okay, text block. Okay, right. And this is if full user is not present, right? So if message dot tool use is not equal to nil, we process here message dot text is not equal to empty. We process this and we need else if message is not equal to nil. We process tool result, right? Okay, quickly, this is fine. This tool definition, content block parameter. But new tool result block. Okay, this should be here. ID start tool result dot content and dot. This should be wrapped around user message. So result is part of user. Tool use is part of what else? Put any name. Tool use ID. Tool use dot use dot name and name. Name is the third attribute, right? This is message dot tool use dot and this should be assistant, right? Else here start system. We might have to write some generic logic here. There's no system message. Oh, there is system. It is there. Then you might remove system. Okay, so we did this transformation correctly. Also, for now, we are hard coding one model, but we need to see what we can do. Okay, we got this translation. Now I have to translate this tool definition into, let's fetch this part of code. Okay, this is super broken now. Get this right. Let's do one thing. Let's abstract this out. what is what is, what is the type of this is content params. Is it okay, paste params. Okay. Okay, we have to union type. Right. Okay, now we are on to using the tool abstraction. So we have to create this union. This code is settled, but now we need a different way of tool definition itself, right? Let's create another folder called tool. Okay, another package called tools, and here we'll try system. This is file system tools, right? We'll migrate this from here to there. Okay, we are 50 minutes into the stream and we are a bit far from to get to a stable state. Okay, now let's just target moving Anthropic for now. Okay, let's pick up the pace here. Right, so we have tools, file system tools. Right, the first type of list files. Right, this is a type dot tool definition. Right, we need a name. Files, description, schema. How do we define our input schema as interface, right? Let me think a little bit. Okay, this is fine, right? Okay. Instance of this, right? Okay. And the final is funct. Okay, let's write a this implementation, right? List file implementation this function everything else goes inside. Let me fix this. Oh, this is anthropic specific. I cannot use this. Okay. Okay. Mm, this is not here, right? Did I? For now, we will say that a instance of our struct itself is what is required. Just files to. This should be enough. Implementation of this file should be, so pull it from there, but first you don't have directories, right? We have our input is list file JSON unmarshal return error. Okay, this is fine. Then here we can do input dot direct. This is easy, right? Assume. Okay. You don't need to get this, right? I just do join new line. Right. So this is our list file implementation. Let's create a region. Right. Okay. List file is there. Now, now. So we have defined it here. So we have to do for en tools. So this is empty to start with, right? Tool param dot append tool param. Name is this. Description is anthropic string description. And what else is there? Schema. Okay, this is where we have to do the transformation, right? From right. Let me refer to my notes of how to do this. Need this generic stuff here. Need is right here. The input schema is a generate or schema. Actually, let the refactor this to say instance, right? That is all. We have to convert them back into messages. Tools. Okay. The final thing remaining here is to convert the messages back into generic messages, right? So this for messages in right response messages. Why is that? Can return multiple, right? Okay. Okay. Hmm. Right. It's inside the switch content. I just refer to the content. Completed the inference part as well. Let's hook it up and let's see if it's working, and then I can call it a day. Okay, so this is all until user call is defined. Then you will create a client saying new client, LLM client provider is Anthropic. Right, we got hold of client. Right now, our input messages is LLM. Right, our first message is role is here. Text is put messages is converted here, 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 here. We don't need. We just need uh, all tools will say and the first element here is list file to dot list file to right. Okay, now what we can do here is send this to client, run inference, input messages or error as well. Okay, let's handle it. Let's do 50 for now. This is gone. Okay, we're close to closing in on it. Right now, whatever the response message is, right? Response message. If message dot text not equal empty, we do this, right? And say dot to use not equal to nil. Okay, here also we are printing, right? Message dot input to dot input dot dot right. Okay, this is gone. Add back all the messages here. Right. Execute tool at present. Right now we need tool result, which is LLM. Right. Do the same thing, which is switch this. If log.tool is not equal to nil, prepare response, prepare tool error, and execute, right? Now the thing with this is we have a generic method to do this. We don't really need any of this. Let's create a function called execute. And the name input is either get a string or an error. There's some problem with my keyboard. There are too many T's. Or let's just do where do we get the access of tool, right? Okay, so the problem is we need some list of this tool definition somewhere stored, right? Let's say for now let's hardcode a to map list file is execute will do is this is execute, right? Okay, what's wrong here? Well, okay, now we have tool definition. We print a pen, prepare tool result. Okay, we were here, right? So let's do tool execute tool log start name to response and error. Not do this actually. Let's just send it direct. What's wrong? Okay. Okay, I think yeah, we've done a lot of work. We have not changed any functionality as such. Let me just actually write it there, there, get rid of this altogether. Okay, system tool, refine, right? This, refine. So this is implementation. This parse the input. The part is the part should be okay. So refine, refine, right. So and we need a tool definition. Okay, we have the second tool definition ready. Add it back here. In main.go, where we declare all tools, let's add tool.run. Okay, now the moment of truth, we just do everything from scratch. So it's reading the root directory. It found all the paths, it's reading all the paths properly. Right, okay, so we didn't lose any functionality. So I think this is a good place to wrap the stream. So what we did in this stream was to lay the groundwork for us to be able to support multiple models for our agent. So currently we had integrated with Anthropic directly, but now we created an interface via which we integrate to Anthropic and everything is working fine. So in the next stream, we'll just switch to Claude and its implementation. Cool. Thanks everyone for joining. See you folks next stream.